Hi guys, I'm back. So let's get straight to it. I sort of made a change on the 3D drawing, and as you can see, we now have a rotor. As promised, we're gonna work on the rotor, and there are going to be two flat discs, and they're going to have iron bars. And well, let's look at how it looks from the inside and why it's made this way. Let's get rid of one of those plates. So yeah, so here's the basic idea. You have those coils and those flux guides. They're going to connect the magnet to the coil for the induction to happen. And in order for those flux guides to be there and the magnets to be held in place, obviously we need the rotor plates. So they look like this. Well, these are the top plates. So the thought behind this is that because these plates are here and the flux guides want to attract obviously to the iron cores and move like pivot on the magnet, so that's not possible because we have these plates and they're holding the flux guides in place so they don't wiggle around, sort of like that. And also then we have this, let's see, it's kind of hard to see. Okay, so here we have these plates which hold the flux guides like in the other sort of dimension, so like they don't move left or right, you see. So that's that. And yeah, it's kind of going to be a little bit different than this drawing. This was just the setup. Oh no, actually here it is. You can see the inside here of this plate is sort of hollowed out. So there's no way for me to make this on the high pressure laminate. But what I can do is make different plates on top of each other, so that there can be this hole here. And the reason for the hole is because the motor, the shape of the motor, you can see it here. So as you can see here, the core material of the iron core from the coils is below where the top is of the starter plate. So we sort of have to have the bearing here, and then it has to move out and then go down a bit. So it's like a bell shape. So that's the thought. And then obviously this is what it's going to look like, this sort of bell shape and the bearing in the middle. And as you can see, I try to make it as accurate as possible. So this is a 6mm plate with a 3mm plate on top, so that will be 9mm. And the flux bars are going to have the similar dimension to the magnet, so that's going to be 10mm, so it'll stick out a little bit. And what's not seen on here is something that's going to keep the bearing from moving up or down. So I measured the bearing and I figured out that in the first place I was going to have this plate hold the bearing in place, but the bearing is also 9mm, so there has to be another plate on top here. And it can be a smaller one, and as we are cutting out this part here from the 3mm plate here, we're going to have some material left, and it's going to move from the bottom sort of plate to the top, so it'll be stuck on here so that the bearing is also stuck into place. What mostly matters is that if there is a sort of force moving into some direction, there has to be a counteracting force in order to stop it from moving. So that's what I'm trying to do here. And obviously these things, the rotor is going to spin fast, and then these flux guides, they're going to you know, try to fly out, like move out, you know, like disintegrate. So there has to be a sort of like ring around it to hold it, and we'll be looking at this later. So what I did is you know, print out the sketch in 2D and then started cutting. And man, this is so easy to do, because look, this is what I got so far. So you have this material and you start cutting it, and you know, I realized that it's so easy to like make the bend, so it was, you know, easy to cut it out at once. And so I did a couple of those. This is the 3mm plate, and here we have the 6mm plate. And obviously there still needs to be a cutout here for the flux guides to fit in, and the bearing hole needs to be cut out, but we'll be doing this later. I thought it would be nice to just show you the idea behind it and the 3D drawing so that you can get an idea. So now I started measuring the weight, because, you know, it feels kind of heavy, and yeah, I can't really tell you how much unless I start measuring it. So that'll give you an idea. So it's basically one on the bottom of 3mm, and this is going to be a cutout, but it's going to move to the top, so one of these plates will do just fine for the weight measurement. And then we have one of those 6mm plates. It's going in the middle, and then on top we have a full plate without cuts. So that's going to be about yeah, I was gonna say 580, but apparently this time it's 522, 27-ish. Whatever. So this is going to be about how much. And obviously we're also going to have iron. Oh wait, it's not zeroed out. Maybe that's why. Let's do this again. Yeah, it's more like 690-ish. So this is about 3 centimeters. We're going to have flux guides that look similar, but they're going to be twice the length. So this is about 50. Wait, what happened here? I swear last time I measured it was 50, but okay. Right, it's going to be about 30 grams, so the twice the length, that'll be 60. So I guess you could say times 4, 240 grams. Add it all up and you get a whole lot. So at first I thought there would be 5 or 6 magnets stacked on top of each other, or like 6 or 7 magnets stacked on top of each other. But as you can see, I've cut it flat on this side, and I left some like the original model on the top so that it looked like the original. And that's going to leave very little air gap. Probably is great for induction, but also we have to consider the cogging and the strength forces on the rotor. So probably we'll end up using 8 of these magnets, just like this. And yeah, that's gonna have some weight to it. So this is actually a magnetic scale, like it attracts if you put it on there. So I put this plate on it to measure it. Oh wait, so this is the 50 grams. Okay, so these magnets are 50 grams times 4, so that will be 200 grams. All in all, I believe we're about making a rotor which is going to weigh about 2 kilograms. This is a lot. So that's it for now, and keep you updated. So thanks for watching. See you next time.